And this actually gets us now to the end of the kind of the history and the overview. And I will hand it over to Jonathan now, who will, going into the next session, the next 15 minutes or so, we're going to talk about some of the latest updates and some of the new features. I think you may have to share your screen then. I'll just stop sharing here quickly. And there we go.
Can we
yeah, I see your screen. Yep.
Okay, outstanding. Well, thanks so much, Koenraad, for that really great overview of the history of GeoPhires. And I'll be briefly covering the latest status and an overview of what's happened since many of you might have heard about GeoPhires at GRC 2023. And I'll just be covering a high-level view of the work that we've done in the last 9, 10 months, whatever it's been, and a brief overview of the UI, and that'll be a segue into Koenraad going back and getting into some more depth on the details of that work. So there we go. So today we are announcing GeoPhires version 3.5, and this is primarily a milestone version representing that work that we've done. And so in GRC 2023, we announced GeoPhires X or 3.0. So this is the 5th minor version change. And we'll just discuss some of the key points here, key features that are part of this. And if you've been following GeoPhires, if you've been regularly updating it on your local machine or using the UI, you may have seen these features, you may be aware of them, but for many of those of you who are probably not, this is for you. So briefly, we've got new subsurface designs and surface applications, including, as Koenraad mentioned, we've got AGS or closed loop, we've got absorption chillers, heat pumps, district heating, Sutra, a number of others. So we're really excited to share those with you, and we hope that we can meet everybody's needs in terms of the surface application that they want. We also have some new case studies and model calibration. Obviously, this is important because GeoPhires is a model, and its value lies in its predictive power. And although there is limited data available, especially on next generation geothermal right now, we've been able to calibrate with some of the available published data and show that GeoPhires is predictive of real-world data. We are going to show how it can be used to model forward-looking techno-economics for larger projects. We have also integrated standardized data where it's available. So, for example, updated drilling cost correlations, and that was with Byron, whose last name I'm not going to try to pronounce right now, but thank you to Byron at NREL for working with us on that. We've also integrated standardized water and steam properties from IAPWS, which is a common engineering reference standard for water and steam, and that has allowed us to refine our results across all of our examples and case studies to hone in on better accuracy, and so we're happy about that. That work also enabled us to support super hot rock temperatures and pressures. We will be discussing that in a bit more depth, but the key point there is that you are now able to use GeoPhires to model up to 600 degrees Celsius. Now, there are a number of caveats to that, but this is the first step in terms of truly being able to do that SHR resource modeling, and even just based on those initial results, even though we know that some of the correlations may need further refinement. We're very excited about having taken the first steps and also done the underlying engineering work in the code to ensure that that was all consistent and standardized and provided a foundation for a number of software engineering best practices, and in fact, that has been my primary contribution as a non-geothermal expert, is being able to work with these amazing experts in the geothermal space and bring my expertise in software. And the sum is greater than the whole is greater than the sum of the parts, where we're able to ensure that the knowledge that our expert contributors has is encoded in a way that is robust, standardized, professionalized, and establishes GeoPhires' credibility as a piece of software that is going to be long-lived and is going to be stable. And like any other software, it will have issues and bugs, but tracking, resolving, and continuously improving them. So I'm really excited about the state that we're in, and I hope you guys are going to find some value in once we get in a bit more depth on some of these points. So very, very brief history from a software versioning standpoint. Kunrad covered the broader history, but so we had 1.0 in 2014, 2.0 was a big version, 3.0 in 2023, and then 3.5 today. As I mentioned earlier, it's a milestone version, and it is an incremental version that's leveraged the modularity and extensibility that was introduced in 3.0. And this is another just recap of some of the subsurface designs and surface applications. Again, we will be getting into those in some more depth shortly. These are some of the case studies that we'll be talking about. I won't go into these at the moment, but to just prime you guys for what we'll be discussing, we'll be looking at some of the FERVO projects. We may get to discussing the well drain clause correlations and the water and steam properties. A bit more on the superhot rock. As I mentioned earlier, we're supporting the superhot temperatures and pressures up to supercritical and 600 degrees Celsius. I will mention, from a technical standpoint, I believe the upper bound on what we can support from a programmatic standpoint is actually, it might be up to 12 or 1400 degrees C. We kept it capped at 600 for now because we thought that was a reasonable point in terms of the material costs will be substantially different at these higher temperatures as is, and we just wanted to put some cap on it. We have a couple of examples demonstrating some potential SHR techno-economics. We also, for those of you who are familiar or interested in regional geothermal resource assessment, we have GeoPhires also includes a HIP-RA module, so that's heat in place resource assessment. We have a new version of HIP-RA that we are calling HIP-RA-X, which supports supercritical resources. And there's been some, we'll be discussing a case study, and we may also mention some other work that's been done with that's exciting. And we'll also be discussing in some more depth, there's a swath of future work and a path forward for SHR modeling that a big part of this workshop is we want to really hear from you as users what you're interested in, what you would like to see, and we'll get into that. But as you can see briefly there's the power plant efficiency correlations. There is handling potential mixed phase in a more, some of those correlations. We would love to be able to model the corrosive effects of a bit more, well, at all, I would say. And then also looking at the supercritical CO2 Brayton cycle plants. And then another thing that we'd like to bring to your attention is the web interface, since we will be using it. We also hope that people who may be less technical or even myself as a technical person, I prefer to use the interface because it's easier, and we've put a fair amount of investment in terms of incrementally making this more user-friendly, and there are some areas where it has a ways to go, but we hope that you guys will find this to be convenient and especially for newer people getting over that intimidation factor. So just to briefly review this, we've got our tabs here. So we've got the quick start. If you've never used this before, you can just go ahead and hit run example, and you can use that drop down to select an example if you care to. And so as Kunrad mentioned, we've got our case report here. We've got the parameters. And so to briefly touch on what Kunrad said, so you can enter a text file, and you always will be able to do that. And then we've also got the more sophisticated editor that tries to guide you a bit. Now, we would love to continue improving this interface and making it more guided, maybe even having a wizard sort of experience. But this we hope is a little easier than manipulating text files on your local machine. And we'll get into some more detail on using that and some of the features in the later sessions. We also have examples, because those examples are often the best way to find the closest example to your project and start from there as a reference point. And so for each example, we've gone and we show the pre-computed results for it here, and then we have the parameters you can briefly review from here. And yeah, for me personally, I think it's pretty interesting to be able to look through and just at a glance see what some of these numbers are. As I mentioned earlier, we've got some super hot rock examples. This is sort of, to me, that's an exciting break-even price to see, and we would. And then you also have the ability to save results, and then also you can share them. So I've got this cogen with isopentane result that I just shared, and if I send that to somebody, or even paste it in the chat, you can share those results. So even if you're not necessarily using this interface to do your core work, you can use it to create. You can take a GeoPhires result that you've made locally, and then you can share it with your colleagues. And we hope that that's a nice feature for you. Let's see. So very briefly, a couple of more new features. We've also got production and investment tax credits, overpressure or overpressured systems. We have a variety of automated test coverage that falls under the software engineering. We've got automated documentation generation on the documentation site, and I may cover that in a later presentation, time permitting. We've got a Monte Carlo simulation module and client, which is a more advanced usage to do exploration across multiple parameters. We've got the UI and GTP, so the platform is under my business scientific web services geothermal platform, so that's what that means if you see it. And then also just highlighting that we have been tracking and resolving issues, and to date I think the number of issues we've resolved is 77 or 78, which is great, and we hope to continue that cadence. I'll also just briefly call attention to the volume of usage that we see of GeoPhires, which I think is really interesting and indicative of how many people are interested in GeoPhires. It's indicative of activity in the geothermal industry in general as things heat up, so to speak. But yeah, I am seeing on the web interface, these are some monthly metrics. So this is a rough approximation of the number of analyses we see on the web interface. So last month it was over 1,600, and that is approximately in line with what we've been seeing. We've been seeing an increase. So it's really exciting to know that people are are really actively using GeoPhires. We're also, this is last month's snapshot of the geographic location that we've seen. We get visitors from all over the world. Diana, what are the benefits of creating out proactive updates is something that we would love to implement, although right now the best way would be to watch the GitHub repository, which actually that is covered in the slide after this one. Some quick metrics for what has happened from a code and activity perspective. Since version 3.0, we've had 6 contributors. So there's three core contributors, myself, Kunrad, and Malcolm Ross. But we've also been able to pull in some other contributors. I believe Byron's on the call. We also had some university students. I'm not sure if you're on the call, Nat and Amelia, but hello if you are. And I believe we had one other person who I'm so sorry if I'm forgetting, but it's great that we have an active contribution team and development team. We've had 83, maybe even 84 as of today, pull requests that have been merged. And now commits and lines of code they're not the best metric for code quality, but just to give an indication of the level of activity that has been happening. We've had, at the time that I wrote this presentation, over 860 commits and 360,000 lines of code that have been changed. Now that's code, those are lines that have been added and deleted and changed. So the entire code base is not this big, but just as an indication of the volume of activity that's been going on, it's quite high. And that's a good thing that you want to see in a healthy code base. This is a graph of the volume of activity over time. So we'll go through periods where we have more feature releases and contributions, but you can see it's been steady activity since September of last year. And oh, did I not? I thought I had another slide. That's okay. Oh, here, yes, GitHub Insights. Yes, so Diana, you can, on the GitHub repository, I would recommend everybody here create a GitHub account. Just in general, it's a good thing to have. It's the easiest way to engage with us. We have 26 stars. We have 6 people watching, 6 people that have forked. This is a snapshot of the traffic on the GitHub repository itself. So we're seeing that traffic on the web interface and the GitHub repository, and it's just really exciting to see the interest, the usage, and we're hoping that we can translate that into improving GeoPhires and meeting the needs of especially next generation geothermal. And with that, Kunrad, I'll hand it back.